the work that we do in our research group is not so much to develop innovations, but we're very much interested in how the dynamics of innovation takes place and how we can analyze it and how we can understand it better so that we can do it better, that we have higher success rates when people develop new ideas and they want to take it into markets. And one of the important focus areas in our group is that we look or a study, or a lot of the work that we do is about innovation for inclusive development. So just a little bit of background, I always start here that the world is incredibly skewed. Already in 2015, Oxfam said that 50% of the wealth in the world is in 1% of people's hands. And it means that not only is it unfair, but it also can erode democratic institutions. So inequalities have lots of negative knock-on effects, like when a poorer individual or resource poor individual tries to access services, they very to incur higher costs than a person who's better off to access medicine, food, services. And if you have to go and stand in a very long queue to go to the clinic and get to the front and your medicines are out of stock, it may end up in you not even trying to access that service. Or if the goods that you procure is of worse quality because cold chains are just not as reliable in a poorer resource environment, it may lead to non-usage of something like food, for instance. And another very important impact is that poorer people sometimes have to make tough decisions. It's called the catastrophic spending burden. You may have to choose between medical treatment of a family member or having a kid in school. So huge inequalities in wealth, in access to innovation, the kinds of products and services that are developed have very harsh consequences, especially for poorer people. And in a South African context, when we speak about inclusive innovation, we would normally speak about poorer individuals. In a developed country context, we may refer to maybe people with special needs or other kinds of access issues that may exist. But I think in our program, we speak about marginalization, mostly economic marginalization. And what's also important to understand is that one would think that the market or companies can step in and start to develop kinds of products and services that are more suitable for lower income environments. But it's actually very difficult to penetrate those markets. The environments where these services need to be delivered, where they need to be accessed, is difficult to reach. There are skills challenges, infrastructure issues. And of course, this also has implications then for the fourth industrial revolution, how unequal the proliferation of these technologies can be and the benefits of it. So I was hugely inspired by Professor Ori Rip already about 15 years ago. He visited South Africa. He's from Twente University. I was at CREST at this time, at Johan Matton's unit, and he introduced this idea of a grand societal experiment to me. In South Africa, we have a wonderful opportunity. We have a sophisticated economy, or part of it is very sophisticated. We have a strong financial sector, universities. There are lots of multinationals and local companies, but we also have a very big part of our economy or population that's basically excluded from mainstream economic activity. And the idea of the grand societal experiment is how can we leverage what we've got to make sure that we can uplift people and give people access to the services and goods they need to develop. So traditionally, we've been focusing a lot on education, access to food, access to healthcare. But one of the problems is also that when people want to come and help, it is usually individuals that come from a better resource environment or even overseas. And there's this idea of parachuting in with solutions. So to give you one example, medical devices in hospitals, in public sector hospitals, very high percentage of them fall in disuse. About 90% of medical devices that are donated are not used because they can't be maintained. There are issues around if they are suitable for resource poor environments. All these kind of issues lead to situations where even where people try to come in and introduce technologies or integrate new technologies in a developing country context, it's not necessarily suitable. So the idea of innovation for inclusive development is that one has to create, or one has to try and improve the living conditions and to create employment opportunities for poor individuals through the development of new products, services, processes, and business models. And what this means is that it has to be inclusivity in the whole innovation process, from where we state problems, the process of developing innovations, the process of adoption, and the economic inclusion element. All of it has to happen in a process where there's co-creation. So we use a lot of design science research in our program, for instance, just because we need to co-create these frameworks and these approaches with people that will use it. Now, to give you a few examples of inclusive innovations or innovation for inclusive examples, Jaipur food is a frugal innovation. It's very famous. It's a prosthesis that costs $5. A more fancy one with all the bells and whistles will cost $5,000. Then Unjani Clinics, that is an example of inclusive innovation. It's a clinic that the nurse owns, and she operates the clinic in the community where she lives. And it creates a job for the nurse, but it also gives access for people to healthcare. It's a private clinic, and the prices are quite low, but it's pitched the level that it will be sustainable. And Unjani has rolled out, I think, about 200 clinics all over South Africa. So it's a proven, scalable solution. The stock visibility solution is, or system, was rolled out to about 3,000 clinics in South Africa where there are no computers or internet, and it was there to make sure that people can log stock levels in clinics, so that once a week they upload the stock levels in clinics, so that the Department of Health has a much better idea of how to supplement the clinics with medicines. So it's inclusive because it's supposed to help by improving the resilience of supply chains. Now, just a quick introduction to our research group. We have about almost 30 postgraduate students under my supervision and also co-supervision with colleagues. We've been very, very productive the past few years. We've graduated 41 masters, 24 PhDs, and over the past 10 years, we have published quite a lot of articles in the area of innovation for inclusive development. We look at innovation systems. We look at studies that look at values of death, social entrepreneurship. We've looked a lot at technology platforms or the platform economy, how to develop sectors, and then also how some of our tools can be used in terms of monitoring and evaluation. So I'm going to give you a little bit more of an idea of our approach. So we use the innovation systems perspective, and this recognizes that the innovation system has components, which is actors, universities, science councils, companies. They interact towards a common purpose, which is to develop and diffuse innovations. So there's knowledge and learning, there are institutions, regulations, cultures. These are the components of the system. But there are also functions in an innovation system that needs to be performed so that the system can develop and diffuse innovations. And this includes entrepreneurial activity, knowledge development and learning, knowledge diffusion, guidance of search. So where are we going to invest? Where are we taking our technology? Market formation, creation of demand, the mobilization of resources, and then the creation of legitimacy. Legitimacy is about legitimizing the process through which innovation is created, but also the technologies or the business models or whatever is the artifact or the product of an innovation process. And what we've done is we've started to unpack these functions into indicators or activities that one could normally see in an innovation system. So just to give you an idea, for entrepreneurial activity, we've unpacked it into projects with commercial aims, if it's a technology demonstration activity, portfolio expansions, things like that. And the idea of showing you this is just to show how we are using this framework to do analytics of innovation system dynamics. Now, we have been working mostly in innovation for inclusive development, but recently we've started to work also in more traditional innovation sectors like medical devices, medical diagnostics, automotive components, energy, additive manufacturing, and then Professor Mpho, we were touching on rail, but we never actually went into it. But maybe we can talk later on if we can collaborate on something like that. And we have developed a range of tools. I'm going to tell you about 5 of them, but I'm going to explain one of them in more detail. So the first tool is a tool where we use input-output product space maps. It looks at trade data, and it's supposed to look at if we map a whole value chain of the automotive sector, for instance, how can we look at trade data and look at areas where South Africa is supposed to have a competitive advantage? We, for instance, applied this to combustion engines versus electric vehicles to see what components are similar and which ones have to change, and to what extent does this give us indication of relative advantage or competitive advantage. A second tool is the one I'm going to talk much more about. It's about mapping biographies of innovation projects. It's about understanding the whole evolution of an innovation project through event history analysis or process tracing. It is a very useful technique, I think, and I will talk much more about it later, so I'm not going to go too much into this. A third tool is to map the maturity of a sector or innovation systems. So by using these innovation system functions, we have created a maturity evaluation tool, and we can start to see for a specific sector, where does the maturity lie in terms of these different functions. And it's very useful for a policy, to inform policy, because we can see in what areas should one start to think about improved support for innovation systems. Hand in hand with this one is their innovation system industry survey. So we've used those functions that we've unpacked in terms of the indicators, and we've created a survey. And we've rolled out 2 surveys by now, one to the additive manufacturing sector and one to medical devices. And we try to extract insights by mapping the innovation system functions and the indicators, and to what extent industry participants, government people, people in universities experience difficulty, importance, frustrations in terms of performing these activities. And this can inform then, for instance, a very simple 2x2 map that can help us look at policy implications. An area of our program that's under development is system dynamics models of innovation systems. We've built a few of them, but this is supposed to create an environment where we can do what-if analysis, scenario analysis, if we can adequately model innovation systems and how they perform functions. This is one of the least developed areas in our program, but we're very much interested in expanding that. So let me give you a little bit of a better idea how we do event history analysis and the kind of environment that we're building to build a huge database of case studies where we can start to systematically understand in our South African context how innovation projects evolve and develop. So I'm taking you back to the innovation system function, innovation systems perspective or framework. Please recall, we look at the structural elements, which is the actors, how they interact, knowledge, and development, and so forth, and then the system functions. So recall, we have unpacked this in terms of indicators, and what we now do is we have already developed about 25, 30 case studies where we do interviews with innovators and participants in their projects. And what we do is we map the biographies or the histories of innovation programs. And we, over time, capture a range of things. We capture readiness levels on different of technology readiness, market readiness, IP readiness, the different actors participating in different functions, the functions that have been that one can identify from the activities in these projects. And what we then try to do is to start to ask questions about, when we perform these functions, are there systemic issues that we can start to explore in the way that these functions are taking place, and what are the reasons for issues in the system? For instance, actor issues. Is there an issue around being actors present or missing? Are there capability issues? The way different actors interact? Are there missing interactions? Are there institutional issues, regulatory problems? We see it a lot in medical devices that people do not adequately anticipate these things. Or infrastructure issues, missing components, issues in capability. And that gives us a very good idea around the systemic instruments that we can use to try and systemically address issues in innovation systems. Now, let me give you an example of what this analysis could look like. Now, one of my students, David Adeyeye, did a event history analysis on a large program that was rolled out to small-scale farmers to enable them with a range of services on an online platform. And what we did was we captured the whole biography or event history analysis of the whole program, and we could carefully unpack, according to the indicators and the events that took place, what functions happened where, and we can start to track when negative events happen. We can also look at the cumulative effect of functions. So this is a simple heat map, one of the visualizations that we've created. We've also started in our program to integrate actor role theory. So actor role theory says that there are some actors in the system. It could be a project developed by the CSIR, where the CSIR was rolling out tablet technology to schools, and there were about, I think, 30 schools in the whole program, multiple actors, and we mapped, for instance, in that case, the whole program from where its inception through pilots, through scaling, and we could identify about, let's say, 10 or 20 actors. But the important thing is that actors play different roles over time. So yes, we can look at the actors. This is back to David's example. We can start to see where in the process were some actors involved, what were their roles, and what helps to do that is then, for instance, in this case, where I'm showing now a map showing how different actors play multiple roles in certain events, and also how actor roles change over time. So it's very common that, for instance, in a project that is initiated through a science council, that the initial champions would be the CSIR, for instance. But at some point, when the pilots are over and there needs to be scaling and implementation, roles need to be handed over. And it's very useful to use this technique to see overload of certain actors. At some stage, some of the actors had to play multiple roles. It's interesting to see over time how it changes, and also where some roles have been discontinued. And for instance, a champion or funder role does not exist. So this technique can help us to understand the actor roles better. Another element that we've included in this whole event history map of biographies of innovation projects is also readiness levels. So we've adopted readiness levels by some Swedish people at the Karolinska Institute, and they have quite a lot of granularity around different readiness levels of innovation: customer readiness, technology readiness, business model readiness, intellectual property rights, team readiness, and funding readiness. So if we start to map out these histories and we get this rich set of information, for instance, the readiness levels can also be mapped over time. And what's really interesting is to see how these readiness levels co-evolve over time, or how they move up and down. Sometimes a project reaches a point of technology readiness level, but then drops back to a lower level because of certain combination of events. Could be that funding pivots or the project pivots. There are issues with stakeholders. Sometimes the technology just runs into, or the team runs into technical issues that necessitate them to go back to the drawing board. And the co-evolution of this, I think, is also super interesting. Now, I've been presenting this as separate elements, but it becomes really interesting if we start to look at the interplay between readiness, actors, events, roles, functions. So what we are building in our environment is now a platform where we can start to have an environment where hopefully we haven't built this yet. We are still doing it quite to some extent manual, but starting to use AI and all kinds of techniques to speed it up. but to create a platform and a technology where we can capture the information, do the data analysis, build the narratives, create a database, validate it, and then there's a visualization element where we can visualize different components, but also start to look at how these different elements interact and may co-evolve or create archetypes of barriers or valleys of death to innovation. And one of my PhD students who graduated March created I think it is Power BI environment where we can visualize these things. We can upload a data into a system, and then we have a whole range of visualizations that I've just explained. And I've now have about 3 or 4 students in it's undergraduate students, but hopefully they will move into masters to start to automate the process of taking the qualitative information from interviews, project information, and start to help build these narratives. Of course, we will not just take it at face value, but it will help us speed up this process. Now, what is really useful if we start to use AI, and of course, we've got now this incredibly rich set of attributes of different events and how they co-evolve, we can start to extract really interesting things from case studies. So one of the case studies looked at biosensors created at the university. We could, for instance, and I'm not going to go through all these insights, start to look at the technology readiness maturity, but then there are scaling issues, typical of university projects. The uptake pathway is not necessarily set up. There could be very weak finance ties. A lot of these projects may rely mostly on initial funding or master's funding, which is basically actually a human resource development instrument, not necessarily innovation funding instrument. We have, for instance, seen that role handovers create major readiness valleys. So when people hand over or leave or change, there's a lot of discontinuity. And these insights on a case study level hopefully will also contribute to us being able to look at this on a higher level so that we can start to do meta-analysis and understand the general issues within certain contexts. So our vision and our program is that we want to build this further. And the idea is that we want to create the world-leading innovation system analysis platform that can help us combine extensive empirical evidence through case studies, but also through some of the other tools, and help us to create practical tools for practitioners, for policymakers, to help us understand innovation dynamics better, to have a much richer set of support mechanisms for especially smaller companies or individuals or university systems or accelerators to look at how they can more strategically support innovation projects. So our objectives will be to expand our empirical base. We are aiming for 100 case studies. I think if we can speed things up and build the system where we can start to more systematically analyze projects, it will lead to that point. For instance, I think I've recruited one of the Innovus people. They've approached me, and hopefully we can look at portfolios of projects at Stellenbosch University and see how we can use these techniques to look at how to manage portfolios. What are the kind of reasons that spin-out companies, innovations, access markets do not succeed? What are the combinations of issues faced, and how can one better support that? That's just one implication. My dream would be to go and do this for science councils with huge portfolios of projects to see if we can build an empirical base for them around that. How can we use very rich monitoring evaluation reports, project reports, all these kind of things to understand the dynamics of the innovations and support systems. Then the meta-analysis framework is something that is the next phase. I've got about 4 PhD students or master's students upgrading or converting to PhD, where we'll be taking this further. And what we want to do is to create an environment where we can appropriately lump projects together and see what are common lessons from these environments. We can also create archetypes of different kinds of contexts and see what would emerge from that. We are hoping to collaborate with some of the AI professors in our department whom we've had discussions with, that we can integrate more data science into how we do this, pattern identification, clustering, and see how we can use our empirical base, hypothesis development, and also synthesizing the lessons from these cases. And I think this also will then pave the way to see if we can start to develop better forecasting and warning systems. Hopefully, the system dynamics modeling will also benefit from this. And I think something about the early warning systems and how we can design this is that the structural indicators of innovation systems, actor diversity metrics, our networks and interactions are working or not working so well, institutional issues, functional indicators, for instance, knowledge development, entrepreneurial activities, all these kind of things can help us look at combinations of issues that may lead to problems. Yeah, and then of course, I think interaction indicators, contextual indicators, and these kind of things will also be very, very important in this endeavor. So, in a nutshell, this is the kind of work that we're trying to do to explore and understand innovation systems. And I think it has potential also, of course, to look at projects where fourth industrial revolution innovations are developed, but also where people try to adopt these technologies, and to what extent can we explain the speed, the success, the scale that can diffuse in systems. So yeah, I think that's enough. I am 3 minutes short of 30 minutes, but of course I'm open for discussions and connections. And then if anybody just want to explore possibilities for case studies or collaborations, I'm very open to it.